All right, today with section 2.5, we're going to continue with that and kind of just enhance things and make things a little bit different. All right, today's a little bit of an interesting section. 2.5 continue today. We're going to be rewriting equations with only variables. This will be a little bit abstract for us at first, and I hope you just stick with it and stay with me for a little bit and understand that this is going to look weird and it's going to look a little goofy, but it's something that's good practice and it's something that's pretty important, okay? So an equation that has only variables, this is a good example. H equals f times x minus s. Notice there's no numbers at all. And what we're going to be doing in this is rewriting this equation in terms of just x, okay? So we're going to solve for x kind of similar to what we did with the previous section, or the 2.5 in the first part of it, where we were just solving for a y. In this, we only have variables. There's only an h equals f times x minus s, and we're going to solve this thing for x. Okay. Some hints that I have for you guys. Okay. Number one, imagine every variable besides the one that you are trying to solve for is a number. Okay. So in this case, we would imagine that h is a number, f is a number, and s is a number. And then we're going to just rewrite it using the equation properties of equality, or we're going to kind of work backwards to try and solve for that s. Okay. So our first example, we're just going to use this one, h equals f times x minus s. All right, our goal is still to isolate that variable that we're solving for, so we're trying to isolate x. Okay, now if we imagine that h, f, and s were all numbers, all right, and we worked in reverse order of operations to try and solve this kind of like a two-step equation, all right, instead of subtracting s, we would work backwards and we would add s to both sides. All right, add s. Now, this is going to be really, really important to show all your work, okay, which could be an issue for some of us. So, if we add s to a minus s, or a subtraction of s, these two are going to cancel off, and over here, again, we do to both sides of the equation the exact same thing, still produces an equivalent equation. We've got h plus s. So over here, all we're going to write is h plus s, okay, equals f times x. Now, the second step to this two-step equation would be to divide by f, all right? If we were to imagine those were all numbers, all right, we would subtract, or we would add to cancel off our subtraction, and then we would divide to cancel off our multiplication. So that's exactly what we're going to do here too. We're going to divide this whole thing by f, so our f's cancel off, divide this whole thing by f, and we're just left with h plus s divided by f is equal to x. Okay. So again, we're just following our properties. Again, it's more good practice and kind of reinforces the fact that our properties are very important, right? And we need to follow those properties. Let's take a look at another example. Y equals x minus v over b. If we imagined all those were numbers and we were just trying to solve for x, again, we're solving this for this variable. All right, we're trying to solve for x. I'm going to get rid of that so we keep it clean. If we're trying to solve for x, the first step that we would do here would be to undo that fraction, or undo the dividing by b. Okay, so the first thing we'll do today is just multiply by b on both sides, times b. Okay, all we'll be left with then is b times y, or by, is equal to x minus v. And the opposite of subtracting v would be to add v. So now all we're left with is b times y plus v, again we did this on both sides, plus v, is equal to x, and we've solved for x. Now again, this is a pretty abstract concept. Since there are no numbers, it can make things a little difficult. Follow your properties and imagine that you see every single variable that is not the one that you're solving for as being a number, and then try and work it that way. Okay, so our answer for this one would be b times y plus v equals x. Now again, this is kind of an abstract concept because we don't have numbers, but stay true to your properties and we should be in good shape. Okay. Now this one, there's a special trick. If we see a times x minus b times x equals c, this a times x minus b times x, notice they both have a factor of x. They're both multiplying by x. Now this one can be tricky because if we were to try and solve for just one x, okay, there's two of them here. It's kind of tough to figure out which one we would isolate for. So what we're going to do is we're going to think of the distributive property, and that's the hint that I give on a problem like this, a times x minus b times x. Okay, distributive property basically says that if we have a times b plus c, that is going to be equal to a times b plus a times c. Okay? Notice in this case, we've got a times x minus b times x. Both got a common factor of x, just like in the kind of the basis of the distributive property, they both have a factor of a. Okay, so what we're going to do is we're going to pull that x out front. Alright? Pull that x out front, and then write the rest of it like a distributive property problem. We're going to pull this out, pull our other x out, and all we're left with is just a minus b. Okay? Now this one's kind of tough. It's an interesting concept. So we pull the x out front, we're left with a minus b is equal to c. And since we're solving for x, we've got a times the quantity of a minus, or x times the quantity of the a minus b. We're going to divide this whole thing by a minus b to finish it off. Divide by a minus b. Okay, a minus b over a minus b, poof, they're canceled off. X is just equal to c over a minus b. Now again, kind of a abstract concept here, the distributive property ones. Again, anytime you see two factors, if you see an a times x minus b times x and you're trying to solve for that, chances are you're going to have to distribute, or basically kind of do the reverse of the distributive property. Okay. One or two more examples and we'll call it good. Solve for x. We've got x over f equals y over h. Now if we wanted to isolate x and we were starting with x divided by f, what's the opposite of dividing by f? Would be multiplying by f. So in this case all we're going to do is multiply by f times f. X then will be equal to y times f over h. Okay, that was a little bit quicker. Not as bad. So with these variable expressions, again, you've got to really stay true to your principles. That distributive problem is one that can get a little tricky as well. But we'll work on it again in class, and hopefully this helps. All right, thank you.